Hi, this is Dan from Update My Dynaco in Akatika. A question I often receive is how do you check diodes and transistors to make sure that they're grossly functional? That's what we're going to go over today. So what I've got is standard Radio Shack meter, nothing very fancy. It has an ohms range, and if you notice, we can zoom in on that a bit. There's a select button on this meter, and we'll hit it 2 times until we get the display that shows the diode on the right side. Yeah, the right side of the display. Now, what this meter does is it puts a current out of perhaps a milliamp and then shows what the voltage is with that 1 milliamp. And when the diode is forward biased, you get about 0.5, 0.6, 0.7 volts. Depends on the diode and how much current. Now, if we flip the diode over, we have put it in a non-conducting direction or reverse bias direction. And what we see is an overrange indication. And what that says is it's an open circuit. And we can see that it's an open circuit because it's the same thing we get when we just do that. And what it is that the diode in that particular orientation is reverse biased. Turns out we can use exactly this diode check to check transistors. So an actual reasonable equivalent model, at least for checking gross continuity and function of the diode, is that the transistor, in this case an NPN transistor, has a diode equivalent model that looks like this. And this is once again NPN. And the reason is because we've got a cathode or a negative terminal, a cathode or a negative terminal. So there's an N, there's an N. And here in the center at the base, we have 2 anodes or positive terminals together. And it turns out that if we treat the transistor as a pair of diodes, we can check each of the diodes. And if each of these diodes check OK, then grossly the transistor is working, not burned out, not shorted. Let's go ahead and do that. So one thing that we often might want to check is a power transistor, because power transistors are most likely to become abused and to die. So we can use this diode test on a power transistor and see how it works. This is an NPN power transistor that some people use for replacing the output stages of stereo 120s. It's a nice transistor. And it has the collector, and either this one or this one is the emitter or the base. I never remember. But you know, if we know that it's an NPN transistor, well, we know that if we stick the positive lead on the base, then if we go with the negative lead to either the collector or to the emitter, we should get about 0.6 volts as a reading. So I'm just going to guess that this transistor lead here is the base. I don't know if I'm right or not. And let's go over here. We get an open. And so it looks like I didn't do too good job of guessing. So let's say this guy is the base. Let's give him a shot. All right, we've got about 0.463 volts to the collector and about 0.504 to the emitter. So what we've seen now is that this indeed is an NPN transistor. We know that this terminal here is the base. And we see that the base to collector diode, because the collector is the case, is 0.462 volts. That looks good. And the base to emitter diode is 0.503 volts. And what we can do too is, just to make sure nothing is funny, if we flip the leads and check reverse polarity of both of these diodes, it should show us an OF indication for both tests. And it does. And finally, what we could do is we can go from the emitter to the collector. And because we have 2 diodes in series, but with a flip of polarity, there should be no conduction in either direction from collector to emitter. And this one we said was the emitter, and we go to the collector and there's nothing going on there. And we reverse our leads, nothing going on there. So grossly, we know at least that this transistor probably works pretty well, and at least that it isn't shorted out and won't do horrible things to us when we run our test. We can also do this test for a PNP transistor. There's a little different mapping between the polarity of the diodes, the base, the emitter, and the collector. But if you just follow this sheet, you can see that the base collector diode has this polarity, and the base emitter diode has this polarity over here. And you can use that same technique to look for either a low voltage of about 0.4 or 0.5 or 6 volts, or an OF condition to see that everything on the PNP transistor you're testing at least is grossly functional. So now you know how to use the diode check on an ohm meter to check diodes, and more usefully, you can use it to check transistors to make sure that they are grossly okay and not blown up, so that you know when you put it into circuits, hopefully good things will happen. Thanks for stopping by today, and catch us next time as we do a little bit more in the world of tech talks. See ya. Bye.